So welcome to the session. Now we are going to see about the construction or conversion of given PDA into CFG. So the given problem is accepted by the PDA, which is accepted by an empty store, and we have to convert our CFG equivalent to this one. So which means variable we have to construct CFG like this following, right? CFG G equal to VTPS. So for the solution for this we have to go for to find out variable. So variable equal to start symbol union q z q dash. So it is q z q dash. So q in this sense will have a set of states which is known as q naught. Maybe it is q naught or q1, and here also it is q naught or okay. So and along with that we'll have this z, which is known as push down symbol here, and in our case is push down symbol is x, right, in stack. So we'll have this one and also we'll have this. So when we see this is a combination. So q naught or q1, and this q dash takes also q naught or q1, and this is always x, right? Okay. So this is x generally. Okay, fine. After that we'll have this start symbol. So when we see this q comma q dash belongs to q and z belongs to tau, which is in a stack symbol, right? Okay. So V is a start symbol or an ordered triple, and whose first and third elements are starts, and second element is a push down symbol. So when we see this kind of thing, we'll have to find out a variable. So variable V equal to, we have to write it, variable V equal to, this is a union operation, right? So along with the start symbol we'll have this. So for this we'll have q naught or q1, and for this we'll have q naught or q1. So q naught, q naught. So this is one combination, and similarly we'll have q naught, q1, right? So we'll have x and we'll have x, right? Okay. After that we'll have this q naught, z naught, q naught. So this is the next combo, q naught, z naught, q1, right? After that we'll have q1, z naught, q naught, q1, z naught, q1, right? Similarly we'll have q1 x q naught, and we'll have q1 x q1. So these are all the variables, which means these are all the non-terminals production over here, symbols, non-terminal symbols over here. So totally we're having 9 non-terminals. So after that we'll have to write in production, right? So production in this sense we have to generate a rule 1, right? We'll have this rule R1. So here S production we need to write. So why? Because for any CFG grammar you have to start from S, right? So we will have to write S production. So S tends to q naught, z naught, q for every q in q. Okay, for this kind of thing we'll have this. For this kind of thing we'll have this two combination available for this. Production 1, production 1 tells you S tends to q naught, z naught, q naught, and we'll have P2, right? For P2 S tends to q naught, z naught, Q. So this is two rules. Okay, production 1 and production 2. Okay, after that we'll have to see this mapping function. So when we see this problem, we have a set of rules which will be divided into two categories, which is known as non-terminal rules and terminal rules. So when we see this 3, 4, 5 and 6, these are all termed as terminal rules, which gives epsilon as an output. So when we get an output as an epsilon, so these are termed as an terminal rules. And when you get some kind of, have this terminal symbols, right? So non-terminal symbols, which means variables available. So this is known as rules, which is known as variables. So it's in non-terminal rules. So this is known as non-terminal rule, and these 3, 4, 5, 6 are known as terminal rules. So for terminal rules, we'll have this. We have to generate rules, right? Rules for mapping function 3, 4, 5, 6 in a given problem. So in a given problems PDA, right? Okay. So when we see this, so these are all generated terminal, which means we have only epsilon symbol. When it is produced as epsilon, this is termed as terminal rules, right? Okay. So see here, so I have to rewrite this production 3, which means, see this one, Q0 for rule 3, you have to take in like this, Q0 x Q1 derives 1. Okay, and similarly Q1 x Q1 derives 1, and for this one Q1 x Q1 derives epsilon, and Q1 is it not Q1 derives epsilon. So we have to rewrite this similarly. So Q0 x Q1 derives epsilon. Q0 x Q1 derives 1, not epsilon 1. Similarly, we'll have, see here, Q1 x Q1 derives 1. Q1 x Q1 derives 1. See here P5, for P5 Q1 x Q1 derives epsilon. So Q1 x Q1 derives epsilon. And similarly you have P6, so P6 Q1 is it not Q1 derives epsilon. So Q1 is it not Q1 derives epsilon. So this is my terminal rules, right? These are all terminal rules. So next one, so from this PDA will generate terminal rules for this. After that we'll have for the non-terminal rules, right? Non-terminal rules. So when we see this non-terminal, we'll have the formula for this. We'll have this formula, which means Q, see this, Q is it Q dash tends to A into Q1, is it 1 Q2, and Q2 is it 2 Q3, etc. Qm is it M Q dash. So when you see this kind of thing, right? So this is this final term and this first term will be the same, and this final term, and which means this is an etc, right? For the next term will be start from Q3, and this previous term's thing, right, it is ended with Qn, etc. And when we see this, right, so when we see this kind of thing, so it should be matched with this one. So Q dash, which will be matched with this Q dash. So for this we'll have two rules, right, for mapping function 1. See this, my mapping function 1, so this is my mapping function 1 and 2, we have to generate it. So for my mapping function 1, we have Q0. So write mapping function 1, okay, Q0 0 is it not equal to Q0 x is it not. Okay, this is my rule. So I have to formulate like this because it is a non-terminal rule. So I have to formulate like this. So we'll have P7. So when we see this, right, Q0 is it not Q0, okay, tends to Q0 is it not Q0 tends to A, which means this one. And when we see this, keep the first two term as same one. So Q0 so we'll have xz, right, so Q0 and we'll have this combination. So what are the thing will have this here, which will be transferred for this triples first term. So if I put Q0 over here, this will be Q0, and this should be matched with this one. So this last term and this last term will be matched with, and in the middle part, one x will be over here and this particular z0 will be over here. So similarly we'll have to write for this, we have to several combination. See here, so when I see this Q0 and one more thing will have this, right, Q0 and Q1 for also we have to write. So what are all the combinations we are taking, that combination we have to see here. So we'll have this one, okay. So when I use the same symbol Q0 x Q1, again I have to write Q1 z0 Q0, right. So x is it as usually split it into two parts and I have to write it. So Q1 and Q1 will be there and Q0 will be matched with this last term. This last term will be matched with, and again P9. So P9 for P9, so Q0 z0 Q1. For this combo you have to write two rules, right. So Q0, so x and you have z0, right. So when we have this Q1, so Q1 will be final one, so Q0 and Q0 will be over here. So Q0 x Q0 is it not Q1. Okay, this is the matched one and this will be matched with this, and finally you'll have production 10. So Q0 is it not Q1, right. For this we'll have Q0 x Q1 and similarly Q1 is it not Q1. Okay, this will be matched and this will be matched. So this is the thing. So this is the way you have to write for monotomies. For mapping function 2, right, for mapping function 2, so Q0 0x we have to write it, rewrite the rule. So mapping function 2. So what is my mapping function? So when I see this mapping function, del of Q0 0x equal to Q0 xx. right? Okay, so for this we'll have this combination, a similar combination which is known as 4 combination. So P11, P12, P13 and P14. So similarly you have to write this as the previous one, right? So see this Q0 x Q0, Q0 x Q0, and have to A, which means 0. So when you put Q0 over here, so this is Q0, right? So Q0 x Q0 and Q0. So first x will be there, second x will be there. Okay, so this is the way. This is the way I have to write it. So Q0 x Q0. So second thing will be Q0 x Q0, second combo, right? So Q0 x Q1 and Q1 x Q0. Okay, third one. So Q0 x Q1, Q0 x Q0, and we'll have Q0. So what is the term kept here, and it will be transferred to this one. So x Q1, right? Similarly you have Q0 x Q1, 0 into Q0 x Q1, Q1 x Q1, right? So see this is the thing, and this is the thing, this is the thing, this. You have to check it out whether it's same or not, and this will be the same, right? This will be the same, this will be the same, and Q0 Q0, Q0 Q0, Q1 Q1, Q1 Q1. So these are the same. So this is the way you have to write. Okay. So now we have generated P 1 to P14 rules. So we'll have P1 to P14 rules are generated. Rules have been generated, right? So now we'll see whenever we have to see the production, so we have to keep the production. What all the production leads to a terminal string, we have to kept in a particular CFG. So and also we'll eliminate the production which are not reachable to a particular thing, right? So which is also not reachable from a starting state. So which is also to be eliminated. So whenever we want to convert a CFG, so already we have seen CFGs, which is removal of unit production, null production, and removal of useless symbols. So same way, when we see this useless symbol, we have to keep the symbols which is only giving a terminal symbol, and also we have to eliminate what are all the symbols which is not accessible or which is not reachable from the starting state, so which is to be eliminated, right? The same rule will be followed over here. So see here, so when I see this, it should be noted. See this, it should be noted. It should be noted that there are no production for the variables Q1 x Q0 and Q1 z Q0. See this Q1 x Q0. So Q1, see my Q1, see my rules. Q1 x Q0 and q1 is it not q0, q1 is it not q0. So when we see this, look at this kind of production. So q1 is it not q0, and we'll have one more, this q1 x q1. So there are no production for the variable. When we see this, so these are all it produces a set of so it produces it, actually it is a non-terminal, right? Whenever it is whenever the rule is applied over here, so whenever we see this particular thing, q1 x q0 or q1 is it not q0, it is always it's a kind of looping, right? Whenever we apply it, it is always generating the same thing, but it is not provided terminal symbol, so it could not produce an terminal one. So there is no production, proper production for this, right? So wherever it is occurred, we have to eliminate. So I just eliminate this q1 is it not q0. So I eliminate it. Wherever q1 is it not q0 available, I have eliminated. q1 is it not q0. Similarly, I am having q1 x q0, right? So q1 x q0. So q1 x q0. So see this q1 x q0, there is no generating terminal symbol. So q1 x q0, I am eliminating here. So these things I have eliminated first part. So after that, when we see this, second result I have found out that no terminal string can be produced or derived, right? Can be derived from q0 x q0 or q0 is it q0. So see this q0 x q0, q0 x q0, which is not generated terminal symbol, right? So q0 x q0, so there is no q0 x q0. So it is generating q0 x q0. Again, it is going to be generated q0 x q0. So when you see this q0 x q0, you will have q0 x q1. So it is provided 1, and we'll have, see this, when we see this rule, so clearly q0 x q0, see this q0 x q0. So when we see this, right, so wherever occurs this particular rule q0 x q0, right, so it generates again q0 x q0, again q0 x q0, but it is not produce a terminal string. See here, so it again generates its own term, right, q0 x q0, but it does not produce any terminal string. And for this also we'll have q0 x q0 and q1 x q0. So q1 x q0 produced, right, q1 x q0, where is that? No, it is also not producing. So that's why I have eliminated that one. So q0 x q0, wherever it is occurred, I have eliminated q0 x q0, just delete it. q0 x q0, right, q0 x q0. Okay, I am deleting this. So here also it is available q0 x q0. I am deleting this. After that, q0 is it not q0. So q0 is it not q0. Where is q0 is it not q0? When you see this q0 is it not q0, it is also not producing terminal string, right? So q0 is it not q0. Okay. So already we eliminated this rule. So there is no use of seeing this. So q0 is it not q0. Okay, so we have eliminated, right? After eliminating all these, so deleting all these productions, we get what all those. So here we left out, right? So this is also wrong. So see here, q naught, is it not q naught? It is not going to be generate anything, right? So q naught, is it not q naught? Q naught, is it not q1? So see once again, q naught, is it not q naught, right? So it is also going to be eliminated from this part, right? Next one, q naught, is it not q1? Q naught, is it not q1? Okay, it is to be there. So q naught, is it not? Okay, fine. So relating all these productions we are getting S tends to q naught, is it not q1? After that we have q naught, is it not q1? So see what all left out now. So q naught, so when we see this, right, see this, for this we will get q naught x q1, which is known as 1, and q1, is it not q1? Q1, is it not, which is going to be epsilon. So it is generating 1, right? So we have taken it out, right? So q naught x q1, is it not q1? Similarly we have what are all the next two will be left out? Q naught x q1, q naught x q1, q naught x q1, and q1 x q1. Okay, after that we'll have all the terminal rules. See here, terminal rules, which is known as q naught x q1 tends to 1, q1, is it not q1, tends to epsilon, q1 x1 q1 tends to epsilon, q1 x q1 tends to 1. So these are the CFG. So now we are converting, hence the given PDA converted to a CFG. Okay, so this is the way you have to convert it. So see here, so this is my conversion. Okay, thank you.